Okay, in the previous video, we concluded that terminologies may help us a lot in the ontological engineering process, and that apart from terminologies, there are many other language resources we can reuse to a certain extent to develop ontologies, or try to enrich available ontologies with linguistic and terminological data. There are many resources out there. You may already have thought of some of them for structuring and defining knowledge: taxonomies, lexicons, thesauri, encyclopedias, glossaries. So what are these resources? And more importantly, what kind of information do they contain? Inspired by Lassila and McGuinness' ontology spectrum, we have classified resources into linguistic, lexical, and terminological resources and semantic resources, according to the semantics they contain. Semantics in the ontological engineering sense, that is, according to how explicit the meaning of or the information contained in those resources is for a machine or software agent, or if the semantics contained in the resource are only interpretable by humans, or let's put this even in other words, according to how structured or unstructured the information contained in them is. So according to this classification, we have placed corpora at one end of the spectrum, since it consists of unstructured text. So a human would need to understand and extract the meaning from them manually, and ontologies at the other end of the spectrum as greatest exponents of semantically structured resources. In between, we have lexicons, terminologies, taxonomies, thesauri, and in the slides that follow, we will have a look at the information or data they contain from a reusability perspective. Taking into account that our final aim is to make the most out of these resources for our ontology development project. In this slide, we see examples of glossaries. Glossaries consist of lists of words and their definitions, and are usually restricted to a certain domain, for example, finance, and that's the most you can get from them. Next, we have an example of an online dictionary, Wiktionary. In this dictionary, and in dictionaries in general, we find definitions of words, part of speech information, grammatical categories, disambiguation according to part of speech, translations, etymological information about the origin of the word, phonetics, about the pronunciation of the words, synonymous words, and other types of lexical relations, illustrations also, etc. Here we see the great amount of translations offered by this resource, for example, yeah? And here we see related terms. And although this is all useful information, there isn't much structure. Here, for example, inside the derived terms box, we find subtypes of rice, rice dishes, or even compounds that contain the word rice. So there's not much a machine could do to understand the relations that exist among the different terms, unless we make explicit those relations for the machine. Another example of a well-known online dictionary is this, the Merriam-Webster Dictionary. Again, many information items here are definitions and examples of use. The next resource I would like us to have a look at is a computational lexicon of the general language, a very well-known one for the NLP community, for the natural language processing community, namely WordNet. Here we also get the different senses for a word according to its part of speech. Is it a noun, verb, adjective? And then we get the different senses for each of them. And a particular way of defining words by identifying a set of synonymous concepts termed synsets. So in the example, we see the word lease that is defined by a set of synonymous words, by a set of synonyms, lease, rental, letting, And these synsets are usually accompanied by natural language definitions or clauses. And that's the way WordNet has to define concepts or to define words. And then there are also some examples of the use of these words, of the use of lists in sentences, in real sentences. The most important feature of such a lexicon is the hierarchical relations that are established between words, between words or senses. So as you can see, there are hyperonymy relations, so the relations between words that are more general than these or more specific than these. There are meronymical relations between this concept and concepts that are part of it, so between an object and its parts. Then there are the traditional lexical relations, synonymy and antonymy relations. So you will agree with me that such relations can be of interest in ontology building. In fact, let me tell you that WordNet has been transformed or is one of the most popular formats in the semantic web. Sorry, is one of the most popular resources in the semantic web. It has been transformed into one of the ontology languages, into RDFS, and is many times used as an ontology. Although some researchers would claim that this is not an ontology, but this would be the topic of another video. So that was WordNet. Our next resource is IATE. IATE is a terminological database, the interactive terminology for Europe. This is a gigantic database with all terms used in the different domains dealt with in the European Union, from finance to agriculture, environment, culture, etc. Terms are associated to domains. And then you get translations in all the languages of the European Union, and also term variants. So by clicking on one of the terms, you get a card like this that describes one term in depth. So you get definitions, how reliable the term is, or the translation, context in which the term has been used. All in all, this is the most important resource for translators at the EU, and the internal version is continually updated. This is not the internal one, but that one is continually updated. Next, Acroboc. Acroboc is an example of a thesaurus. The most particular feature of a thesaurus is that terms are related to other terms by means of 4 types of relations: broader than, narrower than, used for, and related to. And this kind of fuzzy relations can also be taken as starting point for ontologies. And in fact, there is a semantic web language called SCOS that makes explicit those relations so that a machine can consume them. These are thesaurus. Then we have classification schemas. Here, so objects or concepts are arranged into groups based on their characteristics, that objects have in common. Here you have an example from standard classification of aquatic animals. And this can be easily also transformed into ontologies, because you easily identify the subclass of relations because of this, the hierarchical structure followed in these resources. Now, moving on to resources that have some semantics, I would like to talk about Dbpedia. Dbpedia takes as input the structured information in Wikipedia, mainly the information you find in the info boxes, and uses semantic web formalisms to make that information processable by software agents. Here we see, for example, the definition for the concept final list in German, in English, as you see by the relations established. In the next slide, we see information or data values for relations such as has photo collection, has reference, has subject field. So all this information is made explicit for machines, so it is processable by machines. So here we see we can exploit the semantics of this resource. And finally, this is an ontology of the hydrology domain in Spanish, built with the ontology editor Protege, as you may recognize. And as you already know, in ontologies, relations are made explicit and are interpretable by computers, so they are the highest exponent of semantic resources. So in conclusion, different types of language resources contain different language descriptions, definitions, translations, term relations that can be reused at different stages of the ontology development process, or some of them, as we have seen, some of these resources can easily be transformed into ontologies. And in fact, this has been done, okay? So I think you would agree with me that language resources are highly valuable resources for ontological engineering.